if you started to visualize Graham's number, your head would collapse into a black hole. Simply because there is a limit or maximum amount of information, aka entropy, that can be stored in your head. And this limit is related to the size of the black hole that has the same volume as your head. And the entropy of the size of your head carries less information than it would take to write out Graham's number. So the inevitability is that if you started writing out Graham's number, your head would have so much information to store, and therefore it would collapse into a black hole. According to Bekenstein bound, the universe has a finite amount of information it can store. Graham's number is so large that storing it or processing it would require a lot of information than the universe can hold. Graham's number, often cited as the largest number that has ever been used in a mathematical proof in the whole world, stands as a testament to the vastness that numbers can ever reach. But for matters of comparison, before we dig into what Graham's number is, let us first tackle numbers that are a little smaller than Graham's number, such that we can get the bigger context of what Graham's number is. Now, in 1937, a US mathematician called Edward Kastner, very famous in cosmology, was trying to illustrate the vastness of infinity. So he thought of a big number, and so he came up with one with 100 zeros in front. And then he asked his 9-year-old nephew which name could he give to this number. And so the nephew came up with a random name and called it a Google and said, well, okay, that is nice. And so he thought of another big number. So what he did, he thought of 10 and raised it to the power of a Google. And he came up with another number called a Googolplex. Now, for a Googolplex, if you try to write it down, a couple of things would happen. One, the time to write out a Googolplex would actually exceed the age of the universe. Now, a Googolplex is 10 times 10 times 10 a Google times. That is so huge, very huge. 2, you would need more space to write out a Googolplex than it exists in the observable universe. 3, the energy required to write out a Googolplex would actually create a black hole. That illustrates how a Googolplex is actually very big. Now, a Googolplex is actually very, very, very smaller than Graham's number. To illustrate how big a Googolplex is, if you started writing out a Googolplex on each particle in the universe, you wouldn't finish up writing the zeros of a Googolplex. Now, for matters of comparison, a particle is not an object. An object is anything like this. This is an object. But a particle is a tiny fundamental quantity that makes up an object. Now, examples of particles are like quarks, electrons, protons, and so like the size of a proton is 1.6 exponent negative 15 meters. So if you started writing a Googolplex on each particle in the whole universe, a zero on each particle, you wouldn't finish up writing a Googolplex. In other words, you would have no more particles left for you to write the remaining zeros in the whole universe. A Googolplex is too big that if we had a universe that has a diameter of Googolplex meters, and we started moving from one end of the universe, by the time we reach the other end, we would start to see exact copies of the things we had seen initially. In other words, you'd run into the same arrangement of atoms that matches the initial arrangement. I mean, you would actually find out creatures or another person that looks exactly like you. Well, that is hard to imagine, but what does that mean? The difference or the uniqueness of materials or particles would be exhausted, and such that the initial arrangement of particles would start repeating itself. That is how a Googolplex is big. Now, with that information, at least we have laid the foundation and we know how big a Googolplex is. Now, let's dig into how big Graham's number is. Now, we're going to use some mathematics here to illustrate the vastness of Graham's number. Let's start with a number like 3, and we multiply it with 3, or we raise it to the power of 3. which equates to a 27. But there is a more fancy way of writing this by using arrow notation, which becomes a 3 arrow then 3. Okay, so that becomes 27. And so let's try putting 2 arrows in between, and we see that 3 arrow arrow 3. That becomes 3 arrow brackets 3 arrow 3. That becomes 3 to the power of 27, which equates to about 7.6 trillion. Okay, now you see how exponential these numbers are going. And so let's add in another arrow. We say that 3 arrow 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 3. That becomes a very insanely big number, and you can't imagine that, but we are just going to let it there. And so after that, after those 3 arrows, we are going to add another arrow in between, and we say that 3 arrow 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 3, and we say that let that number be G1. Okay, G1 is 3 with 4 arrows inside there. And so after establishing G1, we are going to say that 3 arrow 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 dot 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 3 is equal to G2, for which the number of arrows between 3 and 3 are G1, which means that is 3 raised to the power of G1. Okay, we equate that to G2, and so we are going to do the same 3 arrow 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 3, for which the number of arrows equal to G2, and we equate that to G3. So we are going to do that same thing until we reach G64, and we are therefore going to equate G64 as Graham's number. So if you have seen how numbers accumulate exponentially from 3 power 3, which is 27, then 3 power 27, which is 7.6 trillion, then 3 power G1, 3 power G2, 3 power G3, up to G64, which is Graham's number, shows you the vastness of Graham's number. Now, a few things are known about Graham's number. 1, we at least know the last 500 digits of Graham's number. 2, the last number of Graham's number is 7. So by it being 7, 3, we know that Graham's number is an odd number. Well, yeah, since the last number is 7. Well, where does Graham's number originate from? Graham's number originates from the field of Ramsey theory in combinatorics, a branch of mathematics that studies the conditions under which order must appear. The number was introduced by a mathematician called Ronald Graham in 1971. It was a solution to the problem in mathematics dealing with the edges of an n-dimensional hypercube. Now, we won't go deep in the details of the problem, but I'm just going to paraphrase the problem right here. The problem asked for the number of dimensions needed so that the set of 4 vertices with edges connecting them would have at least one pair of vertices connected by a path of a certain length. Graham's number provided an upper bound for this solution, whereas the lower bound, I think, is 9 or 11. 9. The existence of Graham's number has implications for our understanding of infinity. It shows how large numbers can be constructed to the extent that they bear no meaning in the physical reality. It challenges our perception of finite and infinite numbers, thus pushing the boundaries of mathematics to a philosophical thought. Graham's number even serves as a bridge between finite and infinity numbers. But what is infinity itself? Well, infinity is a concept that has actually challenged theologians, philosophers, mathematicians, physicists, and many other scientists for centuries. It represents something that is limitless, boundless, something that has broken all the finite constraints in the physical world, thus staying fascinating to almost everyone for centuries. The journey into the depths of infinity is a mathematical endeavor that is a philosophical quest that challenges the understanding of reality, existence. From a mathematical point of view, infinity is not a number, it is a type of a number, one that is greater than any finite number, no matter how large it is. It is usually used in contexts like series, limits, and non-standard calculus. In philosophy, infinity is always contemplated as the endlessness of time or space, while in theology it is always related to the divine and ungraspable nature of the Almighty God. This theological perspective helps us to conceptualize infinity as something that is beyond human comprehension, yet intimately connected to the core of its existence. Although not infinite itself, Graham's number is so large that the observable universe cannot contain all its digits. It serves as a bridge between finite and infinite, thus illustrating the limitations of our understanding. If you watched up to this point of the video, thank you very much for watching, and if you're interested in such fascinating sites, please go on. There's a playlist I've created and talks about the physics club. There are a lot more videos that talk about more fascinating insights in science, and therefore go on and watch them. Thank you very much for watching, and see you next time.